computers we use every day are all designed around the same general idea of cooperation of three essential elements: the processor, memory, and peripheral devices. Their names correspond to their functions in a computer. The memory stores the code of a program and data. The processor manipulates the data by executing programs. Peripherals are used to maintain contact with the user, the environment nearby, and other computers. These elements must exchange information for normal operation, so they are connected together via interconnections called buses. Here you can see the generic block schematic diagram of the exemplary computer. You can find the processor, memory, and peripherals all connected via the bus, which represents all interconnections in a computer. The processor is often called the brain of the computer, although in reality it doesn't think. The processor is the element that controls all other units of the computer. We can say that the processor is the device that manages everything in a machine. Every hardware part of the computer is controlled more or less by the main processor. Even if the device has its own processor, for example keyboard, it works under the control of the main one. The processor handles events. Events can be synchronous or asynchronous. Synchronous events are those that processor handles periodically. Asynchronous events occur occasionally. The processor can't stop. Of course, when the power supply is on, even when you don't see anything special happening on the screen. In a personal computer with an operating system without a graphical user interface, for example plain Linux or a command box in Windows, if you see only terminal prompt, the processor still works. In this situation, it executes the system's main loop. In such a loop, it's waiting for asynchronous events. Such an asynchronous event occurs when the user presses a key or moves the mouse, the sound card stops playing a sound, or the hard disk begins transmitting data. For all of those actions, the processor handles executing the programs, or if you prefer, procedures. A processor is characterized by its main parameters: the frequency of operation and class. Frequency is very important information which tells the user how many operations can be executed in a time domain. To have the detailed information of a real number of instructions per second, it must be combined with the average number of clock pulses required to execute the instruction. Older processors needed a few or even a dozen clock pulses per a single instruction. Modern machines, thanks to parallel execution, can achieve impressive results of a few instructions per single cycle. The processor's class indicates the number of bits in a data word. It means that in the size the argument the processor can calculate with a single arithmetic, logical, or other operation. The still popular 8-bit machines have a data length of 8 bits, while the most sophisticated can use 32 or 64-bit arguments. The class of the processor determines the size of its internal data registers, the size of arguments of instructions, and the number of lines of the data bus. Modern processors have additional registers which are much longer than the ones in the main set. For example, in x64 architecture, there are ZMM registers of 512 bits in length. Memory is the element of the computer that stores data and programs. It is visible to the processor as a sequence of data words where every word has its own address. Addressing allows the processor to access variables and to read the instructions of a program, although intuitively the size of a memory should correspond to the class of the processor, it is not always true. For example, in PCs, independently of the processor class, the memory is always organized as a sequence of bytes. and the size of its provided in megabytes or gigabytes. It is good to clarify the meaning of the word byte. A byte is historically assumed as 8 bits of information and used as the base unit to express the size of data in the world of computers. We can't talk about memory size without understanding the term address space. It is the maximal size of the memory which is addressable by the processor. In modern machines, it would be impossible or hardly achievable. For example, for x64 architecture, the theoretical address space is 2 to the power of 64, that is 16 exabytes. Even the address space currently supported by processors' hardware is as large as 2 to the power of 48, which equals 256 terabytes. The size of the memory installed on the computer doesn't have to correspond to the size of the address space. In PCs, we usually have a few dozen gigabytes, which is less than the address space of the processor. On the opposite side, in constrained devices, the size of the physical memory can be bigger than directly supported by the processor. To enable access to a bigger memory than the addressing space of the processor, or to support flexible placement of programs in a big address space, the paging mechanism is used. It is a hardware support unit for mapping the address used by the processor into the physical memory installed in the computer. Peripherals are also called input-output or I/O devices. There is a variety of units belonging to this group. It includes timers, communication ports, general-purpose inputs and outputs, displays, network controllers, video and audio modules, data storage controllers, and many others. The main function of peripheral modules is to exchange information between the computer and the user, collect information from the environment, send and receive data to and from elements of the computer not connected directly to the processor, and exchange data with other computers and systems. Some of them are used to connect the processor to the functional unit of the same computer. For example, the hard disk is not connected directly to the processor. It uses the special controller, which is the peripheral module operating as an interface between the central elements of the computer and the hard drive. Another example can be the display. It uses a graphic card which plays the role of a peripheral interface between the computer and the monitor. The processor, memory, and peripherals exchange information using interconnections called buses. There are 3 such buses. The address bus delivers the address generated by the processor to memory or peripherals. The address selects a single memory cell or peripheral register that the processor wants to access. The address bus is used to select the placement of data which the processor wants to transmit or to from memory or a peripheral. It also addresses the instruction that the processor fetches for execution. The address bus is one-directional. The address is generated by the processor and delivered to other units. The number of lines in the address bus is fixed for the processor and determines the size of the addressing space the processor can access. For example, if the address bus of some processor has 16 lines, it can generate up to 2 to the power of 16, which is 64 kilo of different addresses. The data bus is used to exchange data between the processor and the memory or peripherals. The processor can read the data from memory or from peripherals, or write the data to these units, previously sending their address with the address bus. As data can be read or written, the data bus is bidirectional. The number of bits of the data bus usually corresponds to the class of the processor. It means that an 8-bit class processor has 8 lines of the data bus. The control bus is formed by lines of different purposes, mainly used to synchronize the elements of the computer. In its minimal implementation, it includes the read and write lines, Read line is the signal sent to other elements that the processor wants to read the data from the unit. In such a situation, an element, for example memory, puts the data from the address cell on the data bus. An active write signal informs the element that the data which is present on the data bus should be stored at the specified address. The control bus also can include other signals specific to the system, for example, interrupt signals, DMA control lines, clock pulses, signals distinguishing the memory and peripherals access, signals activating chosen modules, and others. As you will see in the following videos, there will be many variants of each of the elements we discussed: processors, memory configuration, and buses.